Welcome, everybody. And thank you for joining us today. We'll be talking about the math behind hybrid images. But first, I want to stress that at MapleSoft, we say that math matters. That math is all around us in the world, and that knowing math, knowing how to apply it, knowing how to use mathematics as a tool is super important to solve today's problems. Math matters, and our mission at MapleSoft has been to help students around the world to not just learn mathematics, but to develop that deep understanding, that deep intuition, where the concepts are meaningful, have meaning, and where you don't just know how to apply techniques to solve problems, but you know why you're doing it and what you're doing it and what the results mean, which is perhaps the most important part. Towards that mission, we of course offer many products, and one newer product is our Maple Calculator app, which you'll find on the Apple App Store as well as on Google Play. And it's an app that has under the hood all the power that our Maple mathematical engine has, with over 6,000 mathematical functions. But that has a very easy user interface to help you get your results quickly. With the Maple Calculator app, you can even take a picture of some handwritten math, and it will pull it in, understand it, and give you answers. Also, a relatively new product, Maple Learn is a fully online version of Maple. So again, you have the same mathematical power that you used to with Maple, but now delivered in a fully online interface that you just use your browser, go to learn.maplesoft.com, and it's free to get started. And then of course Maple. Maple, our flagship product, Maple that we have been developing for the last 30 years. So very rich, very long history there. And it is in Maple that Nadia today will give you an example of how we are making math come alive, how we are connecting the mathematical concepts with a meaningful way. So to show we're not learning math for the sake of learning math. We're learning math to solve problems. So over to Nadia, and I'm just going to go to an example on the math behind what's called a hybrid image. Over to you.
Thank you, Laurent. So good morning, good afternoon, everyone. So as Laurent mentioned, for today's session, I'm gonna use Maple to illustrate and try to explain you the concept and the math behind hybrid images and use a bit of a fun example. So let's start by sharing my screen. And I stop the video to not lose. Okay, so you should be able to see my screen now. You should be able to see my Maple. So I don't know if some of you remember this picture from 2007 from Einstein and Marilyn Monroe, because it went a bit viral when it got published on the New Scientist magazine. So basically this picture, as you can easily guess, is a mashup that combines a soft focus images of Marilyn Monroe and a sharp focused image of Albert Einstein. So I know that not all of us may be able to see the exact same thing on this image, because this really depends on a lot of factors. Let me explain. If you look very close up of this, very close to this image, you should be able to perceive Albert Einstein's portrait with some seemingly randomly cast shadows. However, if you step back, or maybe squint your eyes or remove your glasses, or even reduce the size of your screen, let's say, you should be able actually to slowly see Marilyn Monroe's face. So for those of you who cannot stand up or change face things, I just like created this little thing to illustrate that. So I've just taken the same images and I've reduced the size. So kind of simulating as if you were increasing the distance from your screen. And now I'm pretty sure that you should be able to see what everybody is seeing. So first, you may see a bit of a blend of the two portraits. So the second image may appear to you as Marilyn Monroe with a mustache, which I don't think really suits her. But if you go really far enough, so if I decrease the size of the image and look at it, you should now see Marilyn Monroe really clearly. And the physicist, of course, face kind of completely disappeared. So this is what we call a hybrid image. It's basically a single picture that combines the low spatial frequency of one image with the high spatial frequencies of another image that will then produce a new image that which interpretation can change with duration, viewing distance, size, also your eye size, basically, your eye size. So I've illustrated that in here, the concept, just to explain you a little bit what is going on. When you take this image, you apply actually a low pass filter to get the low frequency of the image, same thing on the high side, sorry, of the image, and then you combine them together. So this concept actually has been created has been really described in 2006 by a researcher called Dr. Olivia. And what is happening is that unlike what a lot of people can think, this is not magic or this is not your eyes going wrong or anything. It's basically the combination of different spatial frequency in here. Note that the same principle also apply in the real world. This is not just about picture. So let's say if you are standing far away from an object that you are looking at, you will be able actually to see only the low spatial frequency, which means that what you will see is basically a kind of, I would say, blurry part of the image. So you will see the shape, the contour, but not the detail. And the closer you get, the closer you get, sorry, the lower the frequency will be, and the most chance you will get to see the detail. So now that I've explained you a little bit what is a hybrid image and how you can create those hybrid image, I thought that I will show you how to use Maple to create those hybrid image by using two packages. So one of my colleagues actually created this worksheet using the scientist and the Hollywood star picture. But for today's session, my preference went to pets. So I've decided to use a cat and a dog image and combine the two of them to see actually what we get together. So to start, we need to define some support, some procedure, and also some package. So as I've mentioned, we're going to use the image tool package and the signal processing package that are in Maple. And we're going to define 3 different procedures. The first one, the FFT shift procedure, is basically a procedure that is going to swap quadrants of a 2D Fourier transform around so that the 0 frequency component are going to be in the center. The second procedure, the power spectrum 2D procedure, is going to return the spectra of a 2D Fourier transform. And then finally, the Gaussian filter procedure will be used to apply a high or low pass filter in the frequency domain. So here you can see A and B will basically be the number of rows and columns in the 2D Fourier transform, and sigma is going to be the cutoff frequency. Okay, so now we've set up the basics. So let's go and create our hybrid images with Maple. To start, we need to import some images. So as I say, my preference is going for cat and dog. So I've selected a random picture of a cat. Oops, sorry. Sorry, let me execute all of that first of all. And then same thing, a random picture of a dog. So this is our picture that we start with. So you can see really cute face, of course. And now we're gonna transform those image in the Fourier domain. So we're gonna use the FFT shift procedure that we've defined previously. Apply it to the cat and to the dog, and this is what we're gonna get. with unfiltered images. So what you're gonna see actually is that the higher frequency data should be further away from the center of the image, while the high one, the low one, will be in the center of the image. Now that we've applied, we put actually both of our image under the Fourier transform, we're gonna filter the image with a low and a high pass filter. So we're gonna define, first of all, our cutoff frequency. So for the cat, we decided to take 40 and for the dog 5, but you can pick up any number as long as there is a big difference, a difference that is more than 2 between those two data. Now we're gonna apply the high pass filter to the Fourier transform for the cat and the low high pass filter for the Fourier transform of the dog. So let's do that. Let's apply this. And now we're gonna see what the filtered image are gonna look like. So if you followed and remember what I said, the low, the one, sorry, with the high pass filter, you should be able to see blurry images, and the one with the low one are more detailed images. So now we see this. So this is the spectrum, and now let's see the image, what they look like. So you can see a blur. I think I've inverted what I just said, sorry. You can see a blurry image when you use the low frequency and a more detailed image. So you can see actually the sharp detail of the face of the cat with the high pass filter. So I'm just gonna zoom so you can, so you can see a bit better what I'm talking about. So now that we've obtained actually those images, we're gonna add the filtered Fourier transform to both image and invert it to the spatial domain before combining them. So now what I'm gonna do is just combine those two and embedded the hybrid image. And now I'm obtaining my new hybrid image. So same thing as previously. Try to look closely to the image and let me know what you see, and try to go further away from the image. And now you should be, you should be able to see the cat with more detail. So I don't know if I see, So I don't know if you are all able to see it, but just some like hint, because as I mentioned, those hybrid image depends on a lot of factors, whether it's distance, size, also your the quality, I would say, of your view. So you can try to remove your glasses and try to see if you get different things or not. See, I can see that someone in the chat told me that like they managed to see what we get, which is great. So this is a pretty good illustration, once again, on how to use Maple. Two packages, which are the image tool package that I've used to import some images, and the signal processing package used actually to apply a Fourier transform and also different frequency filter.